This is the last of the libraries we need to discuss. And this library has certain functions that are very useful for applications. And so we're going to learn only 3 functions here. There are a lot more in the library, but these 3 functions are very important at this level of computer programming. First one is apps function. We learned about FABS, F-A-B-S. That was same thing, finds the absolute value. But FABS will receive floating point number and find absolute value and return it. But apps, which is also finding absolute value, but this one finds absolute value of integer. So you had to use the right one. If you have floating point numbers to find absolute value of, then you need FABS, which is in the math library. And if you have integer numbers, then you had to use this function, which will find the absolute value of integer. If you use the wrong function, it will convert your number. So you don't want that. Rand function generates a pseudo-random number. I'll explain why it's pseudo-random number, but for now, you can call them random numbers. So random, it'll give you a completely random number, arbitrary. And why is that important? Well, we're going to focus on this function for a while because it is very valuable in advanced programming. So you're going to learn in this level basic uses of this function, but it is also used in advanced computer science very often, like game programming and things like that. Rand function is very useful. SRAND is also related to RAND, and when time comes, I will explain that. So let's proceed to understand the RAND. The RAND function will produce a completely random number. So what is the limit? How large can it be? It's the largest number. It's limited to only 0 to the largest number the computer can handle. Each computer, depending on the size of the computer, the largest number it can handle will be different. So if you want to find out what is the largest number your computer can handle, then you can see out this constant. This constant has that number. Every computer has this constant holding that number. Right, 1 second. So you can just print that number after including the library. Okay, the library is called standard library, but to include that library, you have to write this. stdlib is the official name. Standard library, abbreviated as stdlib. So pound include this to access these functions. If you pound include that and then print or cout rand max, that'll give you the number, the largest number your computer can handle. And you don't really need to know what that largest number is, but in case you want to find out. So the rand function, if I just call the rand function, it'll give me a totally random number in the range 0 to rand max. Okay, so that means if I just generate totally random number, that's not going to be very useful. The use of this function rand is to simulate. Simulation means recreating things that happen in real life. Now, in advanced statistics, it's one of the most important fields, recreating things that happen in life to analyze all the aspects of it. And, simulation is used in advanced space science. NASA does it all the time. So in advanced programming, it's very important function. We're going to use low-level use of, we're going to learn low-level use of this function. And so, for example, I can simulate tossing a die. When I toss a die, instead of actually tossing the die, I can have the computer toss the die. That's basically what we call simulation. So tossing a die means getting a head or tail, two different outcomes. So I just have to toss a die using the computer. I just have to generate a totally random value that's limited to two values, one or the other, so that one can be head, the other one can be tail. Similarly, if I want to toss a die, die is limited to 6 numbers, 1 through 6. So if I just generate a number in the range 1 through 6, that's same as tossing a die. You know, it's totally random. That's what tossing a die means. Randomly coming up with one number in the range 1 to 6. So I can do the same in the computer by generating random number in the range 1 to 6. So the question is, how do I generate 1 to 6? If I just, so let me go to the board and show you. I can simply write a cout statement. After including the library in the program, if I write cout rand, that'll print a random number, total random number. But that number could be, 32,000. So I want to limit the number that I generate. How do I limit? The modulus is a useful operator for that. So if I want to limit the numbers to 0 through, let's say 5, then I can do modulus 6, rand modulus 6. So whatever the number generated by rand is, I'm dividing by 6 and getting remainder. That remainder, when you divide by 6, it'll be less than 6. So therefore, it'll be a number in the range 0 to 6. So this is how it's done. It's very common practice to use modulus operator to limit your random number to a given range. So that's 0 to 5. So, but I want 1 to 6, right? I need a random number in the range 1 to 6 to simulate a die. What I can do is I can do rand modulus 6, which will be 0 to 5, and add 1. Then the range is now 1 to 6. 0 plus 1 is 1, 5 plus 1 is 6. So the range shifts by 1. So by adding a number, we can shift the range. Okay, so here is a bunch of examples. Rand modulus 2 will generate a random number in the range 0 and 1. So it only generates one of two numbers, 0 or 1. And that's same as tossing a coin. When you toss a coin, there will be two outcomes, one, head or tail. So I can interpret 0 as head and 1 as tail, or the other way around. Doesn't matter which one is your head, but tossing a coin is the same as generating a random outcome, and that we can do by doing rand modulus 2. Rand modulus 6 gives you 0 to 5, and if you want 1 to 6, then add 1. This will give you 1 to 6, and that's same as tossing a die. If you want to generate random number in the range 2 to 6, then rand modulus 5 plus 2. The range bottom number, beginning number of the range has to be the number you add, clearly, because the modulus operator gives you number ranging from 0 to whatever. So if you do modulus 5, it'll be 0 to 4. And if you add 2, the range is shifting to 2 to 6. So you can, you can figure out directly yourself, or you can use this formula to figure out the rand function you need. Basically, rand modulus, so to generate numbers in the range m to n minus m plus 1, that's the number you need to take modulus with. So to generate 1 to 6, 6 minus 1, 6 minus 1 is 5, add 1. That gives you 6. So you need to use 6 in the modulus. So you need to do rand modulus 6. That number 6 can be found by doing n minus m plus 1. And the number you add is always the same number as the beginning number of the range, which is m in this case. So the number you add is always m. The number you take modulus with can be found by using this formula, n minus n plus 1. Okay, so moving on, what are the statements to generate random numbers in these ranges? 0 to 9. Can somebody tell me the answer?
Sorry, one second.
Yeah. To generate random numbers in the range 0 to 9.
Can
Sorry,
it
type
be
it.
Yeah. Christopher, go ahead.
Oh no, like I said, you want us to type it correct?
Yes.
Okay, all right, I'll type it.
Yeah, type answer for all three of them. Terence, your answers for the first two are right, but the third one is not. Alexander answered the first one correctly. Christopher, your answer is wrong for the first part. Even for the second part, whatever you answered. Okay, looking at Alexander. For the second problem, it is correct. For the third problem, correct. Okay, and these are Rand modulus 9. Yes, answer for the first one is correct from Anissa. Answer for second one is correct from Anissa. Yeah, Alexander, you have all three of them correct. Very good. Modulus 10. I'm looking at Damien's solution. First one is right, second one is right, third one is wrong. The number you are adding is wrong. Okay, Anissa has the third one right. Very good. All right. All right, you're doing good. I'm just going to present it for those who are not able to see it. 0 to 9. So 0 to 9 means just modulus 10, because you know that when you take modulus with 10, all the remainders will be in the range 0 to 9. So for part A, rand modulus parentheses modulus 10. That's the answer for the first one. Part B, so even in the homework problem, if it says write the C++ statement to generate random numbers in the range, you just have to write C out to be able to print that random number. C out, I'm doing second part, rand modulus 10, that'll give you 0 to 9. If I add 1, it'll be 1 to 10. So that's all we need for the second one. For part C, it's 3 to 16. So you can use my formula if you like. 16 minus 3 is 13, plus if you add 1, 14, the 14 will work. So you can do C out. Even if you don't write the C out, if you just write that, it's right. This is the key. That's what I need to know. So C out the rand modulus 14 plus 3. Always the bottom number of the range, that's the number you need to add. always. So rand modulus 14 plus 3 is the answer for that. All right, moving on. We can now simulate doing things in real life. So suppose that you need to toss a die 100 times and write down the outcome, HOT. Instead of actually tossing the die physically, we can have it simulated in the computer by writing a program, which will toss the die. This program is written to toss the die 10 times and write head or tail, whatever the outcome is. So int I equal to 1, and face is where I'm storing the face of the coin. And while I less than equal to 10. So this loop is just going to have to go 10 times. So I'm starting the I at 1 and going up to 10. That way the loop will execute 10 times. The I is just to execute the loop 10 times. I is a counter, just counting how many times the loop is going. So while I less than equal to 10, here is where I'm tossing the die, tossing the coin. So rand modulus 2, the outcome will be 0 or 1. I'm storing that in face. And if face is 0, I want to write H and a blank next to it. Else write T. I'm interpreting 0 as head and 1 as T. You can interpret the other way around. Doesn't matter. This is all random. So it really doesn't matter what is head and what is tail. And when this program was executed, that's the outcome I had. So it basically totally random arrangements of H's and T's is what you're going to get. And that's exactly what you will expect in real life experiment of tossing this die. So that's what simulation is, recreating things in the computer. So we are doing simple examples in this course, preparing yourself for advanced programming in simulation. You can, in your more advanced classes, we will have to do that.
Professor.
Yeah.
I saw that you include stdlib.
Yeah, that's the name of the library.
Okay, is it because why is that? I'm sorry.
The RAND function
Oh,
is,
because of the RAN, right?
yeah, RAND function is in the stdlib.
Oh, isn't it? Okay. Okay. It's not in the math then, right?
No.
Okay.
That's what we just started out, the standard library.
Right. Okay. Right.
Standard library is the name, but official abbreviated name is stdlib.
Right. Okay.
So that's, and all these .h's means dot header file. Header file is the file where the definitions are, but those files are called header files, and they have this .h extension. And so you have to write that name with the .h extension.
Okay.
All right. So there are 3 functions in this library that we are going to be using: rand, srand, and apps. Apps is very simple function for finding absolute value. But our focus mainly is going to be rand and srand.
And can we use that for the project, the SRAN, or no? Just the RAN, what it says. Just RAN. Okay.
Rand. I'm going to explain srand, but you really don't need it. It's for professional programming. You need it.
Oh, okay. Okay.
So in this class, you don't really need to use srand, but let me explain. You need to understand what it is. The rand, so let me go back to this example. The rand function generates random number, but if I execute this program again, I will get exactly same outcome. This outcome I have here, that's exact same outcome I'm going to get. Why? Because the rand function does generate random number within this program. And within this program, if I re-execute rand over and over, which is what I'm doing here, I'm putting it in a loop. So each time the rand is executed, it'll produce a different number. But if I quit the program and then run the program again, the RAND function is designed to generate the exact same numbers it generated before when you use this program. All right. That's why it's called pseudo random number. Why did they do that? Because if the RAND function actually generates totally different random number every time you re-execute, then if there's an error in the program, it's hard to figure out what that error is. Now, in this level of programming, it's not that difficult, but in advanced programming, it would make it easier if the RAND function generates the exact same random number each time you execute the program. So therefore, they designed the RAND function to produce the exact same random number every time you re-execute the program. So that's why we call those random numbers pseudo-random numbers. So therefore, how do you then make it totally random? I mean, if you market this program, any simulation program in the market, the users will expect the program to generate totally random number every time the program is executed. So that's what they expect. So how do you provide that? That's where the SRAN function comes in. The SRAN function is really it really means seed the RAND function. Seed the RAND function. So here's how it works. If I throw in the SRAN function in my program, I just have to write SRAN anywhere within the program, and in parentheses put a number. This number is called the seed. So as long as this seed remains the same, the program will, the RAND function will generate the same random number. So if I change this seed from 2 to 3 and run it second time, then the random numbers will be different. If I change the 3 to another number, then the random numbers generated will be even different. So as long as seed is changed, random numbers will be changing. That's how they designed the whole thing, so that you have some control over these random numbers. They wanted that. Programmers world wanted that, because otherwise you have no control on the random numbers. So the programming becomes difficult. Finding errors in the program becomes difficult. So when you want to I mean, while you're working with the program, while you're fixing the problems, you don't need the strand at all, or throw in a strand with a fixed number. But then when you are going to be marketing this program, what the professional programmers do is they just throw in SRAND, and then time. Time is another function that will find the time from the clock in the computer. Every computer has a clock built in. And so you need to pass a 0. They throw that in as a seed, because every time this program is re-executed, the time will be different. So therefore, this will be changing. The seed will be changing. So the RAND function will generate totally random number.
I also seen SRAN have unassigned inside of SRAN. I've seen that too. Well, what does that mean exactly?
Uh, no, actually, SRAN needs something, seed. Without anything inside, I will look into that. I haven't seen that. I'll do some research on that and come up with.
Okay.
If you have seen that, I'll see if I
Could
can
you
find
in
that.
theory? Oh, sorry. Can you hear me? Sorry. Could you in theory do like make a variable that's like like in a loop that's constantly incrementing, and then put that inside a strand?
Instead of a strand, no, the point is the RAND function will generate random number within the program. Within this program, when the RAND is executed over and over, it will be producing different numbers. But when you're
Okay.
re-executing the program again, it's going to produce exact same random numbers. In other words, this output will be the same even if you execute this program 10 times. It'll give you the same output. So that means for real application purposes, it's not good. It should produce really random, totally different output every time it is executed, right? So that's what the SRAM comes in. To make the seed different in the SRAM function so that it'll generate totally different numbers.
I remember when doing the code for the project, I got the like same answer over and over, and I was so confused why I got the same output.
Where we never used the RAND function before.
I mean, for this project, yes, you just assigned.
Oh, this project, okay.
Yeah.
Yes, it will.
So that makes sense now.
Yeah, okay, you understand now, right? That's what's going on. It is designed to do that. All right, I'm glad to see that you got started on the project already. Okay, so if you re-execute the program with the same, without the SRAND or with the SRAND with the same seed, then it will produce same outcome each time you re-execute the program. So this one doesn't have SRAND. So if I have SRAND with some fixed number, it'll do the same. As long as you change the seed of the SRAND, it'll produce different random numbers. So that's the point. But you don't need to use SRAND at all. Because in this class, we are just learning to write programs. And so we don't care if it produces exact same output every time you re-execute. So therefore, we don't need to worry about SRAND in this course. It's only for professional programmers. All right, moving on, we're going to do another example on that RAND function. I'm going to write a program that will toss the die 6,000 times. I need to do an experiment of tossing the die 6,000 times and count how many times the phase 1 showed up and how many times 2 showed up and so on. So here's the program. I is going to be my counter to count how many times the loop is going. Phase is where I'm going to store the phase of the die. And count 1 is to count the number of ones. Count 2 is to count number of twos, you know, how many times the 2 showed up and things like that. So I have 6 counters. Here's SRAND 1. SRAND 1, you throw in anywhere within the program. You don't want to put it in the loop, you know, you don't need to repeatedly execute that. Just have that somewhere, and that this way, if I want to get different random numbers when I re-execute, then I just have to change the seed from 1 to 2. So that's why I'm throwing that in. But like I said, we don't need to do that. So you as a learning programmer don't need it. I'm using a for loop to let this happen 6,000 times. I need to toss the die 6,000 times. For loop is controlled. For loop is used and it's controlled by the I, the counter. For I going from 1 to 6,000, I plus plus. This is where I'm tossing the die. RAND modulus 6 plus 1. Now, if the problem says you need to toss the die twice, then you just have to write this statement twice. Phase 1 equal to RAND modulus 6 plus 1, and then phase 2 equal to, again, another variable, phase 2 equal to RAND modulus 6 plus 1. So if you write this same statement twice, then you're tossing the die twice. In one of your homework problems, you need to do that. And then if the phase is 1, then one counter increases, phase is 2, counter 2 increases, and so on. So I have 6 counters, so whichever the phase is equal to, the appropriate counter will increase. And basically that's all I need to do. So this is going to do exactly the same thing as you sitting down and tossing the die 6,000 times. So that physical work is eliminated by doing a computer program. So all I had to do after the loop is to print the outcome, the results of the 6 counters. So here's my output. See out, phase, that's column title I'm writing, phase, and then using set width 13 frequency. Now here's another use of the set width function we discussed in the last class. I'm saying after writing the word phase, use the next 13 spaces to write the frequency. But the word frequency has only 9 letters. So that means there'll be 4 blanks in front of the frequency. So that's going to give me a 2-column look. There'll be blanks after the phase and the frequency, the word frequency. So I'm getting that blank. Instead of using tab like we did before, the tab will move it to a specific place. Instead, I want to move it by 4 places. I want to have 4 spaces in between the word phase and frequency. I can have that by using set width 13. Okay, so after that, write the column, write the number 1, and then with set width, after the set width 13, I write the count 1. So the number 1, phase showed number 1 987 times. That's the count 1 being printed. Number 2 showed count 2 times. Number 2 showed 984 times. This is actual outcome I got when I ran this program. The number of times each number showed up are these numbers. So if I don't change my seed for the SRAM and re-execute the program, this output will be the same. I'll get the exact same output. And that's not right for real life programming, right? And that's why the seed, they made it, the seed change automatically for professional programs. So that's just all in that example. So moving on, that finishes that. So let me tell you something. In one of the homework problems, also in the project, you're supposed to toss the die more than once. I think in one of the homework problems, it's twice. So you just say phase 1 equal to rand modulus 6 plus 1, and then phase 2 equal to, again, rand modulus 6 plus 1. By doing this, you're tossing the die twice. The outcome you get in phase 1, the one number stored in phase 1 and the number stored in phase 2 will be different, because within one program, it will be producing random numbers. So phase 1 and phase 2 are 2 different numbers. And I think the problem is about finding you had to take the sum of those 2 phases and do something with it. So you add phase 1 and phase 2, and then do whatever you need to do with that. So to toss twice, you just write the same thing twice. All right, so that's all there is on the rand function, and your homework assignment has some problems on that. And your project is on rand, and this project is easy. It's one of the easiest ones. Nothing difficult. You need to use the function prime, and I already wrote that for you. I wrote that in class, and it's in the book, and you probably have it in your notes. So there's not much, and the main program is just going to be 5-6 lines. That's about it. So it's going to be very easy, but I just wanted you to practice with the rand function. That's why this project is given. Okay, moving on to next topic, which is references. References is an important topic. We will be using it later, so you need to understand that. A reference is basically another name for same variable. So if you declare a variable val and assign 7, like I did here, int val equal to 7, then you're storing 7 in the memory and naming it as val. Now, if I declare a reference to val, and that will be this. A reference to val will be declared this way: int and num. If you put the ampersand in front of the variable name and say equal to val, that means, by the way, int and together is the declaration. That declares num as a reference to val. Num is now reference to val means num becomes another name for the same variable val. So after that, the variable name val represents a memory, which is same where memory represented by num. So num and val represent same memory. So num and val are two different names for the same memory. All right. So that doesn't seem very exciting, right? Why do you need two names for memory? In normal programming, you don't need it, but I'm going to show you where you really need it. And
So it's like copying.
no, you're not copying.
No, right.
The memory cell is the same cell with, now you have two names. You can access that memory with either the name val or num.
Oh, okay.
If you change the
So
num,
it's only when you
val has changed. It changed the val, num has changed. They're both
Got it.
two different names for the same memory.
Got it.
All right, so that doesn't seem really valuable, right? Because, you know, why do you need two names? So in normal programming, when you're writing,
excuse
just a,
me. Sorry, can I ask a quick question?
yeah,
So if you store it into both of them, if you change like the value in val, does it change in num as well? Or is it just,
right. So
it does?
let me put it on the board. Exactly, that's exactly what I'm talking about.
Thank you.
So if I say int val equal to, I'll make a completely different program, 10, right? I stored 10 in the memory called val. So 10 is there. Now I'm saying int and n equal to val. That makes n another name. N, just n is another name for the same memory cell now. So if I now change n by saying n equal to 25, I have changed this 10 to 25. If I see out val, what will be printed?
25.
25, yes. Because by changing n, I have changed val. N and val represent same memory. All right, is that clear now? Okay, so we have two names for the same memory, and we don't normally need it, but it comes in handy when you are working with functions. So I'm going to first present, oops, somebody's here, back. So here's an example, float x equal to 3.5. So I'm storing 3.5 in a memory and naming it as x. Float and y equal to x. That means y is a reference to the same memory that was represented by x. Now I'm saying x equal to 2x and doubling the value. So that's now 7.0. If I see out the y, it's 7.0 because x and y represent same memory. So if you change x, you're changing y. So that's, I already did an example on the board, so it should be clear now that there's just two different names for the same memory. Now, why is it useful? Let's get to the next page. So here's an example. When we did the functions, we understood that when I write square x, I'm passing the value of x to the function, right? Value of x is passed to the function, and x has a 3.5. And if you go to the header of the function, float square, float num, the num is going to get a copy of the x. I already explained that when we did the functions. So what do we get? We get the 3.5 copied into num. So after that, within this function square, you are squaring num. You can change num, but the original value of x here will not change because you're only sending a copy to the function. And you're not sending any access to the variable x. So the function can change num, but it won't change x, right? Because you're only getting a copy of the 3.5 in num. And so num and x are not related in any other way. Only copy is passed. And this is called passing by value. A value is passed by to the function, not anything else. It's just a value is passed. And so it's called passing by value. Now that we have learned reference, let's understand how we can pass by reference in the same function. All right, so let me go to the board. If I write the function this way, float square, and then instead of float num, if I write float and num, a very small difference, it makes a huge difference. Now, let me show you why. Inside the function, to square the num, I can say num times num. And in the older version, we just said return this, or we said store it in another variable, something like that. But now with this method, I can say num equal to num times num, and I don't need to return anything. And I'll explain why. In the main program, I can say x equal to, or float x equal to 5, and then call the function square and pass x. Okay, so in the original method, the value, if I didn't have the and num here, then you will be passing a copy of the 5 into that, and the function will be working with the copy. But what happens here is the x has a 5, and I'm passing the x to num, but here num is declared as a reference. What that means is it becomes a reference to x. So therefore, this memory cell that was named as x is now named as num. It has num as another name now. So when you're working with num here, now you're working with the original memory x. You're multiplying x by x and putting back in x. Num is same as x, so you're putting back in x. That means that num, the x has changed to 25 now. So when I return here, I'm not getting any value from I don't have to get anything from the function. No need to return. Where is the answer? Answer is stored in the same variable x you passed. So I can just simply see out the x to get the answer printed. So why is this necessary? Why can't we just return the answer? Yeah, of course you can return the answer. But you'll see later, in some circumstances, you need to pass, you need to have the function work on the original memory that your data is stored. Instead of getting a copy, the function needs to work with the original memory.
So you are not copying, you're just changing the name. That's it.
We are making another name for the same memory cell where the original data is stored.
What happens if you see out num?
Oh, here in the function,
In the main, yeah, in the main.
If I see out num, no, there's no value in num. It's only within the function, the num becomes another name for x. And when you leave the function, that connection is gone.
Okay.
Okay.
Okay, that was like a lot of back and forth. I see.
Yeah, when you square x is executed, you're going to the function, and now the num becomes another name temporarily for the same variable. And then the num is used inside the function. And if this function changes num, it is changing x. And that's what we're doing here. We're changing x. And when you return, x has changed, but you cannot refer to num anymore. The num is still limited to the function. But the x has changed. So this is, instead of returning an answer, your answer is stored in the original variable that you had a different number. And so the answer is passed back to the main through this memory that you passed on. So the X itself has the answer. Now this is doesn't seem all that exciting, but it is really necessary for in some advanced programming. For example, remember, this is coming up later. We need to swap. I have two variables, X and Y, having 5 and 9. I want these original memories to be swapped. So if I use a different function, if I use the normal way of writing function and pass these copies, you'll be only swapping the copies. That's not going to work. I need to swap these original memories. So you understand the necessity for getting functions to work on the original memory, right? That needs happen very often. So that's where the reference comes in. So just the and symbol in front of the name makes that name a reference to the other variable. Okay, so by using the references, you're passing by reference. That's what we call it. Otherwise, you're passing by value. So the swapping is an example. So I'm going to show you swap as the next example. Here is the function swap. Remember, this swapping was something we did as an exercise a long time ago, chapter 1. But we need to use that here, and we need to use that in chapter 6. The swap function becomes necessary, very useful function. So this function is written to receive two numbers in A and B, and I'm doing the swapping. I'm declaring a third variable. So let me recall the swap on the board. To swap these two memory cell 5 and 9, I need to use another memory, temporary storage, and in this function, it's val. And then I need to copy this one of the numbers into that, and then copy the 9 into this, erasing 5. Then copy the 5 into this. That's the way to swap. So that's what I'm doing. I'm copying val equal to A, copying A into val, then copying B into A. After that, copy val into B. That's all we need to do to swap it. Okay, so here's the main program where I need to swap these two numbers, 23 and 35. So if I call the swap function and pass N1 and N2, and after swapping, if I print N1 and N2, the values you want to get, you expect to get, would be 35 and 23. N1 is supposed to have 35, N2 is supposed to have 23, right? That's what you want, you will expect. But are you going to get that? No, because you're only passing copy 23 and 35. So, so here's what's happening. N1 has 23, N2 has 35. And when you call the function, your function has the A and B to receive these values, right? A and B. So these A and B will be new memory cells created for those names, A and B. And you're sending a copy of the 23 and 35 to that. And so function is swapping them. So function is going to swap these two. 35 goes here and 23 goes here. And when you return, what happens to N1 and N2? Nothing. N1 and N2 still have the same original values. Only the copies were swapped. That's not good. What I need is swap the original memory cell N1 and N2. So can you tell me what change I need to make to this entire program to make that happen? To actually have the original memory cell swapped?
You insert the and sign?
And sign in front of?
Yeah, before A and before B.
Right. Before A, I need to say and A and int and B. That's all I need. Once I do that, I'm not sending copy anymore. None of this will happen now. What's happening? A and B become names for these same memory cells. And these memory cells will be getting swapped. So now it'll be 35 here and 23 here. And when you come back, the names will change back to N1 and N2, but the values have been swapped. So that's where the reference comes in handy. You are able to allow the function to work with the original memory cells rather than copies. And it's a powerful tool, and you will see when we go to the next chapter, you'll see it's very useful everywhere. So just by changing the A and B to and A and B, we make the program work better. All right, so now so I need to explain something. If you put this function swap at the top of the main, before the main, then you don't need a prototype. But if you put it at the bottom, below the main, then you need prototype. Then what will be the prototype? This is the prototype. It's not in comma in, it's int and to mean references. Now the parameters are.
But do you need to add the A and B, right?
You don't, not for the prototype. This is prototype that goes at the top of the program if you put the function at the bottom. Understand? Remember, anytime if you actually write the function at the top before the main, then you don't need a prototype. But if you write the function after the main, then you need to write a prototype at the top that tells the system that there is a function coming up, which is
Right,
called,
right,
right?
right. So that's prototyping, but I see that on the bottom, the function has and A and yeah B.
Right.
And when you prototype it, you don't have the A and B.
Right. You just take away the names.
Oh, okay, okay.
That's what the prototype is. Prototype basically tells the system that there is a function called swap coming up, and it's a void type because it doesn't return anything, and it's going to have two references as parameters. That's what it tells.
Oh, okay.
And that's necessary only if you have the function written at the bottom instead of at the top. If you write the function before the main, then you don't need prototype. Okay, so here's another example. Here's the function average, and this function average receives the two numbers in references. And that means I'm going to work with the original memory cells, right? So the function is finding the average, a plus b over 2.0. And then I'm storing the average in A. And I'm not returning any value. I don't even need to say return. You can say return, plain return with nothing, or even if you don't write return, when it hits this bracket, it will return to the main. And what am I doing here? I'm not returning any answer back. That's because I'm doing it slightly differently. I have, let's look at the main. Float n1 equal to 5.3, n2 equal to 7.5. So I'm calling the function average, but I'm not copying the results that the function brings back, or I'm not printing. I'm not doing cout average n1 and 2. Instead, I'm couting n1. Why? Because the way it works here is the answer is stored in one of the variables in the original program. So let me show you on the board. in the main program, A1 and A2 have been declared. No, sorry, N1 and N2. N1 and N2 have been declared, and N1 has 53, N2 has 7.5, 5.3, that is 7.5, and then now the function is called. Function average is called right here, and N1 and N2 are passed, but they are received in references. That means A and B become not new names for these memory cells, for the same memory cells represented by N1 and N2. And then within the function, I'm finding the average of A and B, storing it in A. That means that's 12, 13. So the average is going in here. The 5.3 is now erased, and average is 6.5. No, let's see, 8, 3.5. So 5.3 and 7.5. Yeah. 12.5, 12.8, so 6.4. Average is 6.4, and that goes into N1. So when you come back here to the main, N1 has the answer. So I'm saying average equal to an N1. So I'm not returning anything, but I'm storing. The function storing the answer in one of the variables, one of the original memory cells. So that is another way to pass answer back to the main. Now, when would you do that? Think about a situation in which you need to pass more than one value back to the main. The return statement can only return one value. And if you know, in the normal way of writing function, you say return this, and that will be one value. You cannot return more than one value. So if you need to return more than one value, you can use this idea and pass by reference and receive the answers back in the two variables that you passed. That is a common practice. Whenever you need to get more than one thing from the function, this is the only way, because function cannot return more than one value. But in this program, in this course, we will never run into a situation where a function has to return more than one value. But I'm explaining that so that in advanced programming, those computer science majors, when you go to advanced classes, you'll be using such ideas. So that's why I wanted you to understand that. All right, so that finishes the section 5.4. And we are going to begin chapter 6. We have enough time for the introduction, or for the, sorry, the same thing. Arrays. This is our last chapter. This idea of array is important. It's used throughout computer science very often, because large amount of data have to be handled in real life problems. And in the past, we have been only doing very limited data, very limited number of data. And even if we had to use many data that the user enters, we wrote the programs to only store one value at a time, receive one value at a time and process it, and then receive the next value, process it, and then receive next. That's how we wrote in the programs in the last section, because we couldn't store all of those numbers. In most cases, you don't need to store, not most cases, in many cases, you don't need to store all of them. You can process, like the last project you did, you analyzed all those data, the stocks data, all the stock prices, and determined whether the stock is worth buying or not. But you never stored all those stock prices in the memory. You had only one at a time, and you processed it and then went on for the next one. That was okay for that project. We didn't need to have all of them stored. But let me ask a question differently. what if I have my grades in my class, all my students' grades, and I want the computer program to write those grades in increasing order or decreasing order. Then to be able to rearrange all the data in increasing or decreasing order, all the data have to be available. So the system needs to have everything in the memory to be able to compare them all and rearrange them. So all of the data are needed sometimes in the memory. Arrays offer a way of storing multiple data in the memory under one name. So you're storing a whole bunch of data under one name, and then there's a easy way to access them using what is called subscript. So once you understand it, it'll be easy, but you have to understand how the subscripts work. So let's begin working with that. So here's the point. The array is necessary if you need to store many data in the memory at the same time and work with them. So a variable is only good for storing one number. So if you want to store a whole bunch of numbers, and if you, of course, if I want to store 200 numbers, I can use 200 variables. Then if I use 200 variables, then even to add those numbers, I have to write those 200 variables. I had to say sum equal to num1 plus num2 plus num3. I had to type those 200. That's not good. That's not, then the program will be working harder than the computer. So that's not the right way. So can we access the 200 numbers in an easier way without having to write 200 names? That's the idea the array gives you. Array gives you a better way of handling all those data using one name. So it's basically offers this subscript. That subscript is a powerful tool. And we're going to see that next. So if I declare an array as array of size 5, then I'm allocating 5 memory cells under one name, num. So an array called num of size 5 represents 5 memory cells named as num bracket 0. The 0 is what we call subscript. So the name of the first memory cell is num bracket 0. Second one is num bracket 1. The name for the whole thing is num, but each one will be identified by a number going in that bracket. That's called subscript. So num bracket 0 represents first memory, num bracket 1 is second one. The last one is num bracket 4, not 5. Because it starts at 0, the last one is 1 less than the size, for 4. So those are the names. So let's say I declare another example. Let's say I declare an array of size int type, an array of type int with the name num and size 10. So name is num, size 10, and integer type. Then I will get integer type memory, 10 of them. So the first one is called num0. It'll have 4 bytes of memory. Second one is num1 with 4 bytes of memory, and so on. Last one is called num9, and that also has 4 bytes of memory because they're all int type, so 4 bytes. Okay, then how many bytes of memory is used up here? Anybody?
And
So
40.
yeah, 40.
oops, sorry, wrong thing.
10 memory cells, each one is 4 byte long. So altogether 40 bytes, right? Okay, so you're using 40 bytes. The interesting thing is that the name for the whole thing is num, but you can access individual ones by using the subscript next to the name. So if I want to access the third one, the name is num bracket 2. Okay, so let's see the next question. How many bytes of memory is used up? I already asked that question. If I declare cval as an array of size 20 of char type, so its char type means you'll be storing characters. Then what is the range of the subscript values? The size of the array is 20. Can somebody tell me the range of the subscript values?
Isn't it 80?
No, the subscripts. First question.
Oh,
0 through 19.
Subscripts go
yeah,
from what
okay.
number to? The subscripts in this case go from 0 to 9. See that? So similarly, what are the subscripts for? Oops. I think I jumped to that. Okay, anyway, let me go ahead and ask that question.
So to 20 will be like 0 to 19, right?
0 to 19, that's the answer, yes.
20 not included, okay.
Yeah, the last memory cell in the array will be called num19, or actually, what was the name? Anyway, the subscript will be 19 for the last memory. I skipped some pages, so I'm going to go back. All right, so this array here is an array of size. Oh, no, okay. No, I'm fine. I'm back. So there are, this array num here is an array of size 10. And so the last element of the array, we call them elements. Last element is named as num9. And if I declare an array cval of size 20, then the last element of that array will be cval 19, subscript value 19. How many bytes will be allocated for this array? Anybody?
Isn't it 80?
No,
Oh, no, it's the char type. Okay.
it's a char type. How many bytes are allocated for a char type variable? Chart
It's one byte, right?
1 byte for chart
Yeah,
type
right.
variable 1 byte. So this array will take up how many bytes?
Just 20.
20 bytes. That's it.
Okay. Okay.
All right. So how do we declare an array? You declare an array by putting the type, just like variable declaration, and then the name of the array, followed by the bracket and the size. That bracket and the size will make it array. So if the array is going to be size 20, then in the bracket you put 20. Now, when you declare that 20 here represents size and it's not subscript, but when you're using it, your subscripts will be now going from 0 to 19. If the declaration was for array size 20, subscript will be going from 0 to 19 when you're using it. So in the declaration, you put the size in the bracket. Later, when you use it, you use the subscript in the bracket, which will go from 0 to 19. So here's the declaration, int num bracket. This is, even though bracket has empty, that is valid declaration. I'll explain later why that is valid, in what circumstances that's valid. But this is the normal way of declaring an array. Float val 200 in bracket. Char cval 15. This is an array of size 15 named cval, and it'll hold characters. Long or long int are same. Long and long int are same keywords. And I'm declaring num 100, size 100 as a long int type. And these are declarations. So how do you, so here's the int num 10. So num is of size 10 declared. And how do you use the array? I can say num0 equal to 15. Num0 equal to 15 means I'm storing 15 in the very first memory cell, which is valid. And here's in the picture, you can see 15 is stored in the very first memory cell. Num2 refers to third one. Remember, because the count is going from 0, num2 is third cell in the memory, getting 9. So there's 9 in the third cell in the picture. If I say num5 equal to num0 minus num2, then I'm saying subtract the third cell from the first cell, put it in the sixth cell. And so the difference between 15 and 9, which is 6, goes into fifth cell. You can see it in the picture now. And the next one says num6 equal to 2 times num2. 2 times 9 goes into num6. And that's 18 going into num6. So these are valid, but do we use it this way? We don't normally use array this way, because an array means there are numbers throughout the array, large number of data are stored, and then to process them, we normally do the same things over and over. So we normally use loop to process array. So this kind of processing, even though it's valid, is rarely needed in a program. Very rarely you need to do things like that, even though they are valid. So very often we use loops, and we'll see examples of doing this in loops. So something like this, num2 divided by 5, stored in fval, is valid. I'm retrieving the third memory cell of the array and dividing by 5. Adding num0 and num2 and storing in num3. These are valid, but we, like I said, we rarely do this in computer programs. We use loops. All right, so we are out of time. You can print array elements like this, and that's valid. Again, we don't do that sort of thing very often. But we'll stop here. We are out of time, and we'll continue this in the next class. But we haven't done enough to do any homework. But Wednesday, after Wednesday, we'll be doing homework on this. All right. Enjoy the rest of the day. I'll see you on Wednesday.